Good day, dear students. Welcome to exercise 1.3. This also requires some basics, but I will not go through any basics. Basics also I will do in the video itself. During the video itself, it's not very advisable to have a basic lecture for each and every exercise. This exercise deals with the type of questions like you will be given root 2, root 3. Also, this is one type of question where actually only one radical is used, root 2, root 7, root 11, these type of questions, these type of numbers. You have to prove these numbers are irrational numbers. They actually are irrational numbers, my dear students. You have to prove that they are irrational numbers. Apart from that, we also have questions like they will be giving you supposing 3 root 5 or 5 plus root 7 or 1 upon 2 root 7 of this sort. These are all different questions. I have segregated them into different groups. These are one type of questions where only one radical is used. There is no binomial, there is no coefficient with them, like there is a coefficient over here. There is no coefficient with them. There is no binomial. They are not placed in the denominator of sort. They are just one radical monomial, that's all. In both the cases, the questions are these only, that you have to prove root 2 is an irrational number, or a question can be prove root 3 is an irrational number. Similarly, root 7 is an irrational number. Second type of questions are this, where they will be telling you to prove 3 root 5 is an irrational number, 1 upon 2 root 7 is an irrational number. Both have different steps to follow. I'll be first covering this. This is one lengthy question. This requires a lengthy solution, so I'll cover this first. And considerably, this is quite easier and very short. So this you will be able to understand faster. You don't have to worry much about this. But definitely these require some more depth and more detailed explanation is needed. Here, root 5, you have to consider it is an irrational number. When you have to prove 3 root 5 is an irrational number, pay attention, my dear students. Question will be prove 3 root 5. 3 into root 5. This whole number is an irrational number. In this case, you have to consider that root 5 is an irrational number. Root 5 is an irrational number. Here, 5 plus root 7, you have to prove this number whole, 5 plus root 7 as a whole, is an irrational number. While solving this, you have to consider that root 7 is an irrational number. So that problem, that part of the solution is taken care of already, that root 7 is an irrational number. You don't have to again prove that root 7 is an irrational number. You just have to prove that the binomial as a whole is an irrational number. Here also the same thing happens. You have to consider root 7 is an irrational number. So here that part is not that difficult. But here slightly lengthy part this is, because you have to prove there is no support for you. Here you have got a support that root 5 is an irrational number. So there is only the one part is there, the other part is already taken care. But here it is not like that. You have to prove each and everything, that whole root 2 is an irrational number. While doing this, you have to understand few basics and you have to follow 2 or 3 important steps. You have to understand those first, and that is slightly complicated to explain and to understand also, my dear students. So prepare yourself, keep your mind sharp, cool, and properly listen to me, each and every word that I am speaking out of my mouth. First and foremost, see what we have to take care. The step 1. When they say you have to prove that this root 2, see, I consider root x, whatever this number is. This root x is an irrational number, you have to prove. Then you should say that, okay, forget, if it is not an irrational number, let it be a rational number. Consider whatever this number is given to you, this number, these questions, consider root x is a a rational number. So, if you have gone through the basics of the lessons, you will know that difference between a rational number and an irrational number is that a rational number can be written in a form of a fraction, whereas irrational number cannot be written in a form of a fraction. And exactly that is what we will be taking advantage of. Because root x is a rational number, so I can write it in the form of a fraction. And remember, not only a normal fraction, fraction in the reduced form. Fraction in the reduced form. Like example, if supposing I have got 12 upon 15. So this is also a fraction, right? This is also a fraction. But then if I reduce it, what? 3 4s are 12, 3 5s are 15. So it will become 4 upon 5. Now these 4 upon 5, this is the reduced form. And what are these 4 upon 5 called? As separate 4 and 5 are what? My dear students, 4 and 5, which are basically the reduced form of fraction. 4 and 5, if you see, are 4 and 5 are co-prime numbers. They are called as co-prime numbers. And this is what you are supposed to do. Because root x is a rational number, I can write root x. Because it is not a rational number, I have considered it as a rational number. So because I have considered it as a rational number, I can present it in the form of a fraction. Fraction can be any two numbers, a upon b, and you have to consider that where a and b are co-prime numbers. And what is the specialty of co-prime numbers? Co-prime numbers will not have any common factor. We can't reduce them further because they don't have any number which will divide them both. That means they don't have any common factor. That means, therefore, HCF of A and B is 1. It will not have any HCF. It will have only one common factor, and that is 1. This is what you have to understand, my dear students. This is what you have to understand. It is slightly complicated, slightly different. You will need to grasp it. I repeat, my dear students, questions based on these type of questions, root 2, root 3, root 5, root 11, you have to prove that these numbers are irrational numbers. Forget. Tell the examiner that, okay, if they are not an irrational number, I'll consider them as a rational number. So you write over there, consider root x is a rational number. So because it is a rational number, I will be able to present it in a form of a fraction. Because rational numbers can be written in a form of a fraction. Irrational numbers cannot be written in a form of a fraction. So I will write root x in a form of a fraction, that is a upon b, and you have to bring it to the notice of the examiner where a and b are co-prime numbers, that is HCF of a and b is 1. They don't have any common factor other than 1. This is exactly what we will break afterwards. As you solve further, you have to bring it to the notice that a and b has a common factor other than 1. That is exactly what you have to go further and bring it to the notice that a and b, which are supposed to be co-prime numbers and which are not supposed to have any common factor other than 1, they have a common factor. And why do they have a common factor? Because our assumption that they are rational number is wrong. They are basically irrational numbers, and that's why they are having some or the other common factor. This contradiction is arising because we have taken the assumption that root x is a rational number is a wrong assumption. This is one part, my dear students. See, this is the lemma. This is the lemma. Lemma. What is the lemma? The lemma is the rule that A and B, because they are co-prime numbers, they will have HCF 1. This is a lemma. I hope my student is understanding. Sorry. This is a lemma. What is a lemma? That being a co-prime number, A and B being a co-prime number, they will have HCF only 1. And this lemma we will break. And when the lemma breaks, we will tell this is happening, this lemma is breaking, because we have wrong assumption over here. And what algorithm we are going to follow for that? What algorithm we are going to follow? What series of line we are going to follow for that? See, there is one more rule, my dear students, that you have to understand. One more lemma is there. One more lemma you have to understand. One more rule, property you have to understand. See, if supposing I will purposely write in the format that we are going to use it. Supposing that we have got that 2 divides, I am writing this in English, 2 divides a square. See what is the rule. If 2 divides a square, then 2 also divides a. Are you getting this? See, what does this mean? 2 divides a square. When I write this in mathematical form, how will I write this? Can I write it in this way? 2 divides a square means a square upon 2. But is this completely dividing? How do I come to know? What is the answer going to be? What is the answer going to be? We don't know. Okay, I can write it. The answer is going to be, supposing C. I don't know what the answer is going to be, but some other variable. So instead of writing like this a square upon t, what I will write is that 2 divides a square means 2 into something is going to be a square. See what I am doing. I'll come across and I'll be coming across that 2 divides a square. That means when 2 is multiplied by some number C, I will get a square. Therefore, 2 also divides a. That means what now? 2 into something will be a. See, coming back, don't worry, I'll explain you more. See, come to some other talk in numbers. You understand better when we talk in numbers, but actually that is not right. I'll try to spoon feed you, but then you have to understand it. Prepare your own morsel, my darling students. See, so I take an example. 2 divides, supposing 4 square. It divides 4 square. So you should, what is this? 2 into what will be 4 square? See, 4 square will be what? 4 into 4, 16. So 2 into 8 will be 16. This is the meaning. 2 divides 4 square, right? 4 square. Next, what you will be telling? Therefore, 2 also divides what? 4. The base alone. So that means 2 into something will be 4. And what that will be? Some other number 2. Same will not be written over here. I can't write again 8 over here. Definitely it will be some different number. It will be some different number. That is what you have to understand. This you have to understand. Later we will be able to realize what I am telling. See, take one more example. Supposing I tell 5. This I am telling you, basically you will be not considering this. You will be getting this 5 into, considering that I am talking in terms of numbers, but you will not be getting them in the terms of numbers. You will be getting them into terms of variables. 5 into something is equal to 10 square. Supposing 5 into something is equal to 10 square. That means 5 divides 10 square. And at that time, what is this number going to be? 10 square is 10 into 10, 100. 5 into 20 is 100. So when you get this, what you will write? Therefore, 5 divides 10 square. Hence, 5 also divides what? 5 also divides 10. And 5 into what will be 10? 2. It will be different number. It will not be the same number. See, try to understand this. This is exactly what I am trying to explain over here, and you will have to write it in this form. You will have to write it in this form. It can be supposing you get 7 into x square is equal to z square. So whether it is a normal number or a square number, you don't have to bother about this. Whether it is 2 into 2 cube is equal to 4 square. So what? 2 cube रहेगा तो भी 2 into 8 ना. So 2 is dividing 4 square. So 7 into x square is equal to z square. Therefore 7 divides z square. Therefore 7 also divides what? Z. And now I will be writing this back in mathematical form. I will write what now? 7 into some other number. Now x is taken over here. I will write y is equal to z. Are you getting? Then next steps are again there. Those I will explain when we are solving, and you will understand everything, my dear students. Okay? So now coming back, taking a quick revision. See these questions, they will be of, we are first considering these questions, root 2, root 3 type of questions. When they give you these questions, prove root 7 is an irrational number. First we will consider that root 7 is a rational number. And because it is a rational number, we can write root 7 in the form of a fraction. Fraction will be a and b, where a and b are co-prime numbers. Why we are taking co-prime numbers? Because we want a fraction which is reduced form. Which is reduced. We don't want 12 upon 15. This can be having plenty of forms. But we want that which is reduced form, where they are co-prime numbers. And co-prime numbers are the numbers who have highest common factor, HCF 1. They don't have any common factor. Okay? And that is the exact rule we are going to break later. And while trying to establish that condition, I know now you are not understanding these words, but you will come to know afterwards. When we are trying to go through the steps where I have to prove that A and B are having a common factor, I will be needing these properties, where if 2 is dividing a square, 2 will also divide a, and that time the factor will be different. Okay, my dear students, let's solve 2-3 questions and then it is finished. You will be able to understand that. I know you all are sharp. Okay, chalo, all the best to me, that I should be able to pass this knowledge to you. So chalo, let us take the example itself. Example, there is no example, this example में कुछ और है, let's forget. Proof root 2 is an irrational number. Fine. Okay. Now first what I will do, solution. Let us consider root 2 is a rational number. Fine. Okay, that is there. So because it is a rational number, hence we can write root 2 in a form of fraction such that root 2 is equal to a upon b. Fine, where a and b are co-prime numbers. This you can, if you want, you can write that is their HCF is 1. Understood this? And this you can label it if you are writing this 1. Point it. Fine. Now coming back to this. So what do we get from here? Root 2. Now coming back to this. Now as what I have explained before, that will be coming slowly, steadily. Will be reaching over here. We will be reaching over here. Okay, fine. How? See here. Root 2 is equal to a upon b. So I will now cross multiply. I will take b on the other side. Root 2 into b is equal to a. Fine. Root 2 into b is equal to a. But see here, whatever examples I have shown you, 2, 2, 5, है ना? 2 into 8, 2 in 5 into 20, 7, they are not supposed to be carrying any radical with them. So here radical is there. To remove the radical, what we have to do? We have to take square of both the sides. So what I will do? 2 root 2 ka square will be 2 into b square is equal to a square. Right? Understood this? 2 into b square. I have took the square of everything. Root 2 square is 2. B square is b square. A square is a square. This I could do only because there was a multiplication sign in between the two. Had there been plus sign, then the things would have been different. I'm trying to explain you because most of the time when students get confused over there and then they do something which is not followed by maths. See, if this would have been root 2 plus b is equal to a, then I would have been required to do like this. Take the square of left hand side and right hand side, whether it is plus sign or a minus sign. If there would have been a plus or a minus sign in between, then I would have to take whole square and then apply the identity of a plus b the whole square is equal to a square plus 2ab plus b square, and likewise I will have to take the square of both the sides. But since here we have a multiplication sign in between, I can straight take square of root 2 is 2, square of b is b square is equal to a square. Now we have reached over here, 2 into b square is equal to a square. Therefore, what we can tell? Hence, therefore, 2 divides a square. From here we are getting what? 2 divides a square. Hence, 2 also divides what now? A. Therefore, 2 into, now see here, b is taken care, c is equal to a. Fine, this also I should have numbered. 2 into c is equal to a. Now, this I have reached. Now see, second I have got square over here, a square, and here I have got a. So I'll square this also. So taking the square of here, what I'll get? 2 square is 4 into c square is equal to a square. Why I am doing this? See the circle what I am going through, the algorithm through to what I am going through. First, root 2 is equal to a upon b. I brought b over here. Root 2 into b is equal to a. And now I have to take square of everything. Why do I have to take square of everything? Because I want this radical to go. I want to get rid of this radical. So, root of square of this root 2 will be 2, b square, a square. And now what I had explained you, 2 into b square is equal to a square. This means that 2 divides a square. And because 2 divides a square, 2 also divides a. That means now again I will convert it into mathematical form. 2 into something. This time I will have to take some other variable. B is already taken. C is equal to a. and now this is a square. I want one more a square over here. So 4 into c square is equal to a square. Why I did that? Because from 2 and 3 we get what? This is a square, this is a square. So these two have to be equal, right? A square is equal to this, a square is equal to this. What we get? 2 into b square is equal to 4 into c square, right? And now this 2 goes on the other side. B square is equal to 4 into c square upon 2. B square is equal to 2c square, right? So now what do I get over here? See, now the arrangement is slightly different. So that's why I bring this over here. 2 into c square is equal to b square. This I am bringing over here. So what do I get from here? Can you guess? 2 divides what? 2 divides b square. Therefore, 2 divides b square. Hence, 2 also divides b. See here. So, here also I should have labeled it. So here you can see, we will label it next time. 2 divides a. We are getting over here 2 divides a. And here we are getting 2 divides b. So that means what does this mean? 2 is common factor of a and b. See here we got 2 divides a. 2 divides b. That means 2 is a common factor of a and b. This is contradicting the fact that a and b has got HCF only 1. That means the HCF of a and b is 2. Whereas it is supposed to be only 1. This contradicts the fact. That means 2 is a common factor of a and b. This contradicts the fact is not a right term, I don't think, because we have to okay. This contradicts the fact that co-prime numbers have no common factor other than 1. Whereas we have got that a and b has a common factor 2, whereas they are not supposed to have any such common factor. This contradicts the fact that co-prime number have no common factor other than 1. This contradiction arises because of wrong assumption that root 2 is a rational number. Hence, root 2 is an irrational number. Hope you understood this. Don't worry, we'll do one more question and then we will go to solve. Then the rest of the exercise will not be that difficult. See, but just go through what I am doing. This is the first step. Let us consider that it is a rational number, and because it is a rational number, I can write it in the form of a fraction where the numerator and denominator are co-prime numbers and therefore they will have HCF 1. And then I will solve them. This is a series of algorithm I am going through. I am solving them, and then I get 2 divides a square. Then this chain goes on, and when this chain ends, at that time I will have to prove that 2 is a factor of a and b both. 2 is a factor of a and b both, and this contradicts the fact that co-prime numbers are not supposed to have any common factor other than 1. I'll take one more example Or should I go to the exercise? No, exercise has got only one question. So I'll better go to example. Example 9. Prove that root 3 is irrational. Fine. Prove root 3 is an irrational. So same thing I'll do. Solution. Let us assume. Consider nahi. Assume. Why? Because we write here na, because wrong assumption. So either assume. Let us assume that root 3 is a rational number. Fine. You can do one thing. You can pause the video and write the steps only up to C. You can pause the video and write the steps only up to A and B here. And then play the video again and see whether you are reaching in the right fashion. And then pause the video when I reach over here, when I solve that question, and go through and reach over here where 2 are the, you get a common factor. And then again see whether you are matching. That is a better way of understanding and better way of solving. So you will be grasping faster and stronger. Let us assume that root 3 is a rational number. Hence, we can write root 3 as what? Root 3 is equal to A upon B, where A and B are co-prime numbers. That is HCF of A comma B is equal to 1. ज़्यादा precise हो गया है ना? HCF of A comma B is equal to 1. Fine. Now coming back over here, this does not require any numbering. So root 3 into B is equal to A. Now we can pause over here and solve. And you reach to that part up to where you can solve. Go slightly go further. And then again play the video. Okay. Root 3 into B is equal to A. So now I will take square of both. So root 3 square will be 3. B square will be B square is equal to A square. So what does this mean? 3. Hence 3 divides what? A square, because 3 into B square is equal to A square, divides A square. Hence, or therefore, 3 also divides what? A. So this part now I will, this you should label. No, this also will require to label 1. 3 also divides A. So this is your 2. Therefore, 3 into some other number you will have to take now, C. 3 into C is equal to A. Now because here you have got A square, so here also I will have to take square of all these things. 9 into C square is equal to A square. This is my 3. So this is A square, this is A square. There are 2 A squares over here. From 1 and 3 we get what? This 3 into B square is equal to 9 into C square. So B square is equal to 9 upon 3 into C square. So what now? B square is equal to 3 ones are 3, 3 threes are 9. B square is equal to 3 into C square. B square is equal to 3 into C square. To better understand, I will write it like this. 3 into C square is equal to B square. So what do you get over here? 3 divides what? B square. Hence 3 also divides B. This is your point number 4. So in 3 we have got, in 2 we have got 3 divides A and 3 divides B from, what is that point? 2 and 4. From 2 and 4 we get 3 is a common factor of A and B. Right? Are you understanding this? 3 is a common factor of A and B. Right? Because 3 is in 2 and 4. In 2 what we get? 3 divides A. 3 is a factor of A. And in 4 what do we get? 3 divides B. That means 3 is a factor of B. So 3 is a factor of A, 3 is a factor of B. That means 3 is a common factor of A and B. But this contradicts the fact that co-prime numbers don't have common factor other than 1. This contradiction arises because of our wrong assumption. Hence, root 3 is an irrational number. Proved. Understood? Fine. So we can go into the exercise, and then into exercise it's not that difficult at all. You can give a try to the first question. You can give it your try to first question, and then you can play the video again. Okay, fine. Shall I give it a try? What is the question? Exercise 1.3. Exercise 1.3. First question is what? Prove that root 5 is irrational number. Chalo students, pause the video, solve this solution, and then come along. I am proceeding. Chalo, I think now you are playing the video back. So I am solving this, and you can correct your answer. Let us assume that root 5 is a rational number. Therefore, we can write root 5 as what? Root 5 is equal to A upon B, where A and B are co-prime numbers. Therefore, HCF of A and B is equal to 1. Fine. Now coming back to this, root 5 into B is equal to A. The radical, I have to get rid of this. So I will take the square of all the 3 numbers. This will become 5 into B square is equal to A square. Fine. So what does, this is a mathematical form. I write it in English. Hence 5 divides whom? A square. Hence 5 also divides A. Means 5 is a factor of A. But before that, I have to label this as 1, and this will be my 2. Fine. 5 is a factor of A. Therefore, what I'll write, 5 into something, c is equal to a. But then I have to equate this, taking square of this, 25 into c square is equal to a square. Fine. So this will be my 3. From 1 and 3 we get what? 5 into b square is equal to 25 into c square. So b square is equal to 25 upon 5 into c square. This cancels. B square is equal to 5 into c square. That is 5 into c square is equal to b square. Therefore, 5 divides b square. Hence, 5 also divides b. And here the mouse is trapped. Fine. 5 is a factor of a. 5 is also a factor of b. From 2 and 4 we get 5 is a common factor of a and b. But ये not चलबे, ये नहीं चलेगा. But this contradicts the fact that co-prime numbers don't have common factor other than 1. This contradiction arises because of our wrong assumption that root 5 is a rational number. Hence, root 5 is an irrational number. Finished. That proved लिखने का I somehow I'm not comfortable with that. तुम लोग लिखो. Somehow I feel that ऐसा मतलब सामने वाले के नाक के ऊपर मुक्का मारा, ये ले प्रूव कर दिया. थोड़ा vegetarian इंसान है यार. Try to understand. Rest is very fine. Second questions and all, you will see the life is very, very, very easy. 1 or 2 examples I will take, and then you will be able to solve that. See example 10. This next that as I told you, yes, these type of questions. This is over now, I suppose. These type of questions are over, and these type of questions you can take this also as a example, but they are both given as example, so we'll better go by the textbook examples. Example 10. Life is very easy over here. Show that 5 minus root 3 is irrational. Fine. See, in this case what happens, root 3 is a irrational number. We know because this is a binomial. When we are going to prove a binomial is an irrational number, at that time life is easy because we know that root 3 is an irrational number. And when we get root 3 is a rational number, this is the contradiction. That you will get root 3 is a rational number and you will tell that but root 3 is an irrational number. Simple. So consider that same way. Consider, let us assume 5 minus root 3 is a rational number. Fine. Therefore, we can write 5 minus root 3 as, so this is simple. Now here we don't have to really consider them as co-prime numbers. You can just claim them as integers. That's all. Where A and B are integers, just simple integers. Why? Because over there I had to break that law that they are co-prime numbers and they are supposed to have only one number one as a common factor. They are supposed to have only number one as a common factor, whereas I am giving another common factor. That law I am supposed to break. That's why I took added properties of A and B. Here I don't have to break any such law. They are just common, they are just integers, where A and B are integers. So what do I get over here after doing this? See here, I now want to only have to take root 3 alone on any one side. I could have kept root 3 on the left hand side, but because there is a negative sign over here, I shift root 3 over and I bring A upon B over here. So 5 minus A upon B is equal to root 3, or root 3 is equal to 5 minus A upon B. Now see here, what are you getting? Now, since A and B are integers, fine, they are integers, A and B are integers, therefore 5 minus A upon B is a rational number. You see, now you'll suddenly feel that integer है तो rational कैसा आ गया? See, every integer is a rational number. See, try to understand. Every integer is a rational number. When I will solve this 5 minus A upon B, you can take any damn number, 5 minus A upon B, 5 minus 3 upon 2. If I solve this, what I'll get? 10 minus 3 upon 2. 10 minus 3 is 7 upon 2. It's a rational number. है ना? Whatever you take any damn number as long as these both are integers. 5 minus, you take any integer as long as you are taking integer. You can't take over there like 2.01, 001, 0001, and then this is going. You can't take any irrational number over there. You have to take this both as integer. You can take any integer. Minus 5 upon 10 और 10 तो डिवाइड हो जाएगा, तो मतलब क्या उसने माइनस 5 अपॉन 8 है ना, तो 5 minus 5 upon 8 will give you 5 plus 5 upon 8, and then 8 5s are 40 plus 5 upon 8, that will be 45 upon 8. Means this is again a rational number. You will get a rational number. You may not get an integer. Here also we are not getting integer. Here also we are not getting integer. But definitely rational number will be there. And if integer is there, then integer also is a rational number. So no problem. है ना? Every integer is a rational number. Every rational number is not an integer. That's why I am writing, since A and B are integers, when I solve this 5 minus A upon B, it is going to be a rational number. So 5 minus A upon B is a rational number. Therefore, now this is a rational number. Root 3 is also rational number. Are you getting this? I hope you are getting. Root 3 is also rational number, but we know root 3 is an irrational number. Again the same thing. This contradiction arises because of our wrong assumption that, what is the assumption? 5 minus root 3 is a rational number. Hence, I am continuing, sorry for this. 5 minus root 3 is an irrational number. Okay? See, it's very simple. You have to just consider that it is a rational number. In any question of this format, you have to follow the same thing. So because it is a rational number, I will write it in the form of 5 minus root 3 is equal to A upon B, and then bring root 3 on one side, rest all the equation on the other side, and automatically that whatever comes over here, that whole combination is going to be a rational number, because A, B are integers. And then you will say that because this whole right hand side is a rational number, therefore this also is a rational number. But we know that root 3 is not a rational number, it is an irrational number. That's all. The topic ends over here. We can take exercise 1.3 back. Question number 2. I am solving. Uh, you will not get anything to solve then. It's okay. You will get. Let us see. Proof that 3 plus 2 root 5 is an irrational number. You can give it a try. See, consider this as rational numbers. Therefore, what you will get? 3 plus 2 root 5 is equal to a upon b. 3 plus 2 root 5 is equal to a upon b. Shift 3 on the other side because it is a term, so that will be shifted on the other side. Then shift 2 on the other side. So whatever is on the other side, they are all having a and b as integers. Therefore, that whole other side is going to be a rational number. And because that whole other side is going to be a rational number, therefore root 5 also is a rational number. You will write that. Give it a try. Try it. Pause my video. Give it a try. Don't worry. And then let me solve. Then refer to my solution. Okay, I hope you have given a try and then you are resuming the video. So I'll solve it for you. Then you can counter check your answer. Let us assume that 3 plus 2 root 5 is a rational number. Therefore, we can write 3 plus 2 root 5 as what? 3 plus 2 root 5 is equal to a upon b. Here, where a and b are integers. Bas, that's all. And then solve this. Root 5 will keep on one side, rest all will go on the other side. So because 3 is a term, first I'll shift the term on the other side. 2 root 5 is equal to, when I shift the term, sign of the term will change, minus 3. Now I have to shift 2 also over here. This will be a problem. So you'll have to first solve this because this 2 has to shift over here, though this has to be solved first. 2 root 5 is equal to, now how will you solve this? Cross multiply first, a into 1, a minus 3 into b, 3b upon multiply this b into 1, b. Okay, what I did? First I multiplied this a into 1, a minus I copied b into 3, 3b upon b into, the denominators also will multiply b. And now I can shift 2 over there. So what I'll get? Root 5 is equal to a minus 3b upon this 2 will go and multiply with the denominator. Fine. So now here you will see, since a and b are integers, therefore a minus 3b upon 2b is a rational number. Remember, rational, because it is going to be some or the other fraction you will get. Even if it is an integer, still it will be a rational number. So therefore root 3 also is a, because this is the rational number, this also will become a rational number, is a root 3, sorry, root 5 is also is a rational number. But we know root 5 is an irrational number. This contradiction arises because of the wrong assumption that what? 3 plus 2 root 5. 3 plus 2 root 5 is a rational number. Hence 3 plus 2 root 5 is an irrational number. Thoko. Fine. So going to the third question, you can give it a try again. मन में आता तो try करो. Don't worry. Don't get scared of wrong, my dear students. Don't get scared of wrong. Wrong teaches you better than me. How much I teach you, better than that, your wrong attempts are going to teach you. Okay, so don't worry of that. 1 upon root 2. Prove that the following are irrational. Here also same thing you will do. 1 upon root 2, let it be a rational number. Therefore 1 upon root 2 is equal to a upon b. root 2 को अलग कर दो and then you will get a upon b है तो वो because a and b are integers, therefore whatever is on the other side is going to be a rational number, and therefore root 2 also is a rational number, but root 2 is an irrational number. Therefore this contradiction is because of the wrong assumption. Simple, that's all. Pause my video, solve it. Maybe now you have solved and now you are checking your answer. So let us consider this thing. Let us assume that 1 upon root 2 is a rational number. So what do we get? Therefore we can write 1 upon root 2 as what? 1 upon root 2 is equal to a upon b in a form of a fraction. Basically a upon b matlab in a form of a fraction where a and b are integers. Fine. Now I'll solve this. So you can do one thing, as it is 1 upon root 2 is there, root 2 वैसे भी अकेला है, just invert into करो. Therefore root 2 is equal to b upon a. Finished. Now since a and b are integers, therefore b upon a is a rational number. Fine, because it is going to be a fraction. Therefore because this is a rational number, root 2 is a rational number, but we know root 2 is an irrational number. Again the same thing, this contradiction arises because of our wrong assumption. What is that? That 1 upon root 2 is a rational number. Hence 1 upon root 2 is an irrational number. That's all. Chalo, go to the second question. Give it a try. Second question. 7 root 5. Pause the video. Solve it. See if you are able to solve. Chalo, I think you must have solved it by now. So let us assume that 7 root 5 is a rational number. Hence we can write 7 root 5 as what? 7 root 5 is equal to a upon b, where a and b are integers. Fine. Now when they all are okay, एकदम से easy है तो root 5 is equal to a upon 7b. I have to make root 5 alone. Now here, since a and b are integers, therefore a upon 7b is a rational number. Hence, this is a rational number. Root 5 also is a rational number. But we know root 5 is an irrational number. This contradiction arises because of wrong assumption that what? 7 root 5. 7 root 5 is a rational number. Hence, 7 root 5 is an irrational number. Thoko time. Chalo, go to the third question and that will end the exercise 1.3. Come on, third. 6 plus root 2. Come on, students, give it a try. Still more easy. I hope you had paused the video and now you have resumed it after solving. So I am continuing. Let us assume 6 plus root 2 is a rational number. Hence, we can write 6 plus root 2 as what? 6 plus root 2 is equal to a upon b, where a and b are integers. Now if I solve this, the 6 only will be shifted on the other side. Root 2 is equal to a upon b minus 6. No solution required. So, since a and b are integers, therefore a upon b minus 6 is a rational number. Fine. Therefore, root 2 is a rational number. But we know what root 2 is an irrational number. Again, this contradiction arises because of our wrong assumption that 6 plus root 2 is a rational number. Hence, 6 plus root 2 is an irrational. That's all. Okay, my dear students, we have finished one more exercise. Fine, and that's all for the day. I think only one more exercise, 1.4 will be remaining, and that is not very difficult at all. I don't find any reason for it to be difficult, but still there are some basics over there also. So, dear students, study well, revise, revise, revise. Always have the habit of when we go for exercise 1.2. See, we have completed exercise 1.1, we have completed exercise 1.2, we have completed exercise 1.3 today. So, when we have completed all these things, after that, you have enough time for with you solve odd number questions of exercise 1.1, 1.2, 1.3. When I am going to 1.4, you should always do that. Solve odd number questions of exercises solved before. Take out time for that. The next day, solve even numbers. As we proceed further, you have to keep on revising. Revision is very, very, very important, my dear students. We have to study a lot. This is a start, okay, Def? And I don't know what type of a start we have got, but definitely we will turn it into a good start, whatever the type of a start this is. It may look awkward or a different start, but if we decide, we can turn it out into a good start. We will work out together, my dear students. Stay home, stay calm, stay focused. With you always, for you always. Love you all, my dear students. Love you all. See you soon together.